Hello, my name is Viesturs Rīdiņš. I work in company MikroTik, and today I will give you insight of wireless technologies. Uh, First of all, I heard the previous presentation. There was uh, very much misinformation because at the moment the Wi-Fi speeds are no near the Wi-Fi. You can easily check the Wi-Fi standard data rates, and at the moment it's 22 megabits max. And no, I don't think it's a good idea to spread misinformation without checking the facts, because the presentation looked more like from a sales point where you try to convince a potential client, not an engineer. That is why it's not the best way to present a technology for engineers. No, that's my opinion. I'm sorry if I'm too harsh. Uh, so uh, I will talk more about unlicensed wireless spectrum, uh, LTE differences between the classical 2G, 3G, 4G, LTE, and 5G. And I will give you a brief insight about the Internet of Things and how the modem communicate with the router. Historically, the first band that was used for user applications and for point-to-point and point-to-multipoint technologies in the unlicensed spectrum is 2.4 gigahertz. The issue with the spectrum is that it is overcrowded most of the time because there's Bluetooth working in the same frequencies, many 2.4 gigahertz applications, and many more. The amount of the frequency spectrum is pretty limited, and by that it's harder to find channels that do not overlap. But the positive things about it, it can reach higher distances. There are records of distances of 200 kilometers and even more. And it penetrates through objects very well compared to 5 gigahertz or 60 gigahertz. The 5 gigahertz offers much higher speeds than 2.4 gigahertz. It has a wider channel selection, wider channels, and by that it can reach higher speeds. The issues, in my opinion, is that it has also the DFS or radar detection channels, which before they operate, they need to check if there are nearby radars, and the rapidly increasing channel widths occupy the frequency spectrum. As the speeds are greater, but the frequency range is decreasing every year. That is why in US there is also 60 gigahertz, 6 gigahertz range available for usage for 8080.11 communication. 60 gigahertz offers high speed and much higher speeds than 2.4 and 5 gigahertz combined, because it has a wider channel width. And yeah, that's basically if you have the 60 gigahertz channel width has the channel width for each channel is wider than the whole 2.4 and 5 gigahertz spectrum combined. But the minuses are the oxygen absorption, low distances, and less channels available. But the most important factor is that it can reach easily 1 gigabit throughput in each direction. Also, with TCP traffic, it will be around 800. And the frequency spectrum is relatively free because not many people are using the 60 gigahertz at the moment. Here we can see a simple 2.4 gigahertz link. I wanted to show a little demonstration. It was used, the link was created via the MikroTik path calculator. The link is from our office in VEF to our previous headquarters in Pērnavsiela. As you can see, the distance is 1.5 kilometers. In this, for this distance, you will get a very good signal, minus 47 dBm, with data rate 300 megabytes per second, which will be around 240 megabits per second in real life throughputs. Don't most likely it won't get such high speed because there's a lot of interference due to the overcrowded 2.4 gigahertz spectrum, and the speed could be around, in real life, could be around, I would say, maybe 40 to 80 megabits per second combined download and upload. Here is a 5 gigahertz device. Oh, I didn't mention the device that was used was LAG2. The LAG2 has a parabolic antenna, and the parabolic antennas are used for long-range connectivity. You could also make a link of 2.4 gigahertz device with about, I don't know, maybe 20 kilometers and more. This is a 5 gigahertz device, LAG5 AC. The speed will be much greater due to that it supports wider channels. If for 2.4 gigahertz device, the channel widths supported are 20 and 40 megahertz. For 5 gigahertz device, the maximum channel width will be 160, but not for this device because it only supports 80.11 AC, and the data rate will be 866 megabits per second with real life throughput around 600 megabytes. The next one is a 60 gigahertz device. It will reach easily 1 gigabit per second speed in each direction. Combined, it would be 2 gigabits per second. No, if you sum if you sum download and upload, and for most part, it will reach lower latency and higher speeds. But you should add a 5 gigahertz backup link in case if there is heavy rain. If there will be heavy rain, then there's a high chance that the link will be disrupted because I will show in the next slide. Historically, the 60 gigahertz range was not used due to that it oscillates with oxygen molecules, and it absorbs very well in the 60 gigahertz frequency range. And it basically means that you kind of hit the air, or the air just the oxygen molecules absorb the frequency very well, and that is why historically this range was not used in radio communication till lately. Here we can see an IoT gateway. An IoT gateway is a device which is basically a gateway for IoT devices like temperature sensors, vibration sensors, pressure sensors, or whatever. It works as a gateway for passing the traffic for developer applications. It basically forwards traffic from the user and devices. And as we know, the IoT is taking the industry by storm, and there are like solutions where this is a unlicensed spectrum. We in MikroTik sell LoRa 8 and LoRa 9 gateway. One is operating in 800 megahertz, and the second one is operating in 900 megahertz. In most of the Europe, it is legal to use 900 megahertz range, but in non-Europe countries or some Asian or other countries, they allow only usage of 800 megahertz channels. This is a simplified mobile network block scheme. As you can see, this is a public network where all the provider data is forwarded to the international gateways and is routing around the world. This part is involved packet core. It basically is used for mobile phone authentication, user plans, billing, and so on. This is the mobile base station itself. It consists of 3 parts. I will give more insight in the next slide. And here we can see the user equipment or mobile phone or router or any device that has 2G, 3G, 4G, LTE, or 5G support. This is our indoor mobile base station in MikroTik. It basically consists of 3 parts. On the left side, there is a packet core, which provides the data flow. In the middle, there are attenuators, or in real life, it would be antennas. The antennas, maybe probably all of you have seen when you see a mobile tower. There are flat, big flat white antennas, and they are covering 300. Usually, they are covering 360-degree territory by 120 degrees each. And on the right side, there are the radio modules, which provides the bands, the bands or the radio frequencies for the mobile connectivity. Like in Latvia, there are used 5 bands. Historically, there was used band 1, which is operating in 2.4 gigahertz, band 3, which operates in 1.8 gigahertz frequencies, band 7 in 2.6 gigahertz frequencies, and band 20 in 800 megahertz frequencies. And of course, recently added 5G band that at the moment operates in 3,500 megahertz frequency. From the radio perspective, if you usually the 8 megahertz band is used outside of the cities because it will cover larger distances, because if the frequency is lower, the radio wave is bigger and it better and farther reaches it can reach further distances and penetrate better through obstacles like forests, mountains, and so on. LTE bands in Latvia. I will bust the myth about the 5G. If the frequency of the 5G is relatively the same, as you can see in the previous slide, the frequency is 3.5 gigahertz. How can we reach much higher speeds than the classical LTE networks? Is there any magic, or what is technology behind it? Here you can see radio modules. Maybe you can spot which one is the 5G radio module. Probably for you, they most likely looks pretty much the same as it does also for me. Maybe the form factor is a key element, but actually the reason why 5G gets higher speeds, it's pretty simple. It's nothing more than simple physics. If for classical mobile networks we use 5 to 20 megahertz channel, it's for 5G the first range we can use channel widths up to 100 megahertz per second, and it is basically the same concept as it is for road. If you have 2 lanes, you can drive two streams of cars. If you have 4 or more traffic lanes, there can the capacity of the road will be much more, and there are no magic or there was a concept like in the previous presentation I heard that there was just a moment, there was issue with 5G that it the millimeter waves that it so yeah, that the radio waves are harmful, and the radio waves could be harmful, but there are regulations. Each radio device, which is a classical Wi-Fi network or mobile network equipment, it has power limitations to limit the power to a level that does not harm the human body, and it is it is it is important factors that should be taken into account. No, like in home, for home devices, 2.4 gigahertz in Latvia, the maximum transmit power is 20 decibel milliwatts, which is around 20 decibels, which is around 200 milliwatts, which is it can't harm the body in any way or form. There are 2 frequency ranges of 5G at the moment in most of the world, and also in Latvia. We are using the first frequency range, which consists of the frequency range 2.5 gigahertz, or the range itself consists from 450 megahertz to 6 gigahertz. Obviously, we can't use 5 gigahertz range because it's used by the classical wireless devices. There are also cases that Latvian telecommunication regulator has antennas, and they check if there are no wireless devices that interfere with the mobile provider networks, like by example using some illegal frequencies that can interfere with the mobile tower communication with the user equipment. Here you can see the modem communication in RouterOS. Basically, the modem is a mini PCI device which communicates with AT-chat commands which are provided in string format. Here you can see how it looks. The graphical user interface, where the data are represented in Winbox. In the log, you can see what the modem is replying, or which commands are being sent to it. And here you can see simple, if you like, by example, input IC ID, or if the pin of the SIM card is ready, it will reply it's okay. Or you can check the IMSI. It will also, what is the IMSI is identification of the SIM card. It will also reply it it will also replace the IMSI code, and which can be later displayed in the graphical user interface. To improve the throughput of the LTE device, you can also use carrier aggregation. It basically means that you combine two or more bands, like by example, the R11 LTE6 card supports various carrier aggregation combinations, and it can improve the speeds drastically. And if the carrier aggregation is supported by the mobile operator, then you will see much higher speeds than it is with using only one band. Also, I want to show you a simple trick how to improve your LTE connectivity if you are I'm sorry, if you are living in a crowded area. Here we can see that, by example, if we live in this home and there is 1, 2, 3 base stations nearby, we can check the identification of the base station, and in RouterOS it is possible to connect to a specific base station. By example, if this base station would be overcrowded, then we could try to connect to this one or this one. Of course, in the city, it most likely will be bad. The capacity will be limited in the at the end of the day when everybody comes home and want to use their routers or mobile phones for connectivity. But in some cases, by example, if you if you live outside of the city, or maybe there nearby are multiple towers, you can also check in the cell mapper the how the antennas are positioned, like the alignment. You can press on the base station itself, and you will see the coverage radius and where the antenna is pointed towards. And by that, you can choose the base station which will provide the best connectivity for you. Also, this could be pretty significant and improve the performance if you are, like, by example, living in the countryside. Then choosing if you use, like, you can use like a mobile router, or you can use LTE device with a directional antenna, like I showed the 2.4 gigahertz antenna, but it will be pretty much the same antenna, but with which will improve the gain of the wireless equipment to reach farther distances, and maybe the tower, which is 10 kilometers further, will provide better coverage than the one which is next to your relatively next to your location. This will be all from me. If you have any questions regarding wireless LTE 2.4, 5 gigahertz or whatever, you can ask me, and I will try to give you a reasonable answer.